All right, this is a review for the quiz on writing systems of inequalities and intro to linear programming. Okay, so for number one and number two, write a system of linear inequalities to model each graph. So just to make it easy, when I refer back to them, I'll call this line number one just to make it easy. So you know what I'm talking about when I say line number one, and I'll call this one line number two. Now, line number one is actually going to be pretty fast. Okay, whenever you have a vertical line, it's always x equals a number. So in this case, it's going to be x, and it's not going to be equal because it's inequalities, but it's going to be x. And you're shading to the right. So look at this. This is 3. This is 4. This is 5. If I keep going, I'll have 6, 7, 8, 9, 10, 11, 12, and so on. So I'm doing x is greater than or equal to 3. Okay, 3 because it's at 3. Line number two. Let's first identify the slope and the y-intercept. So the y-intercept looks like 2. Going down 1 and right 3. So it looks like the slope is negative 1/3. And the y-intercept is 2. So now what we're going to do is we're going to have to pick a test point. Okay, you can test any point that's in the shaded region. Pick any point that's in the shaded region. All right, so what should I do? I'm gonna do this. I'm gonna test the point. I want to choose a multiple of 3 because the slope is negative 1/3 and the denominator is 3. So I'm going to test the point 6. I'm going to go, because 6, 0 might not be on the graph. I'm going to do something like, I'll do 6, negative 2. That must be true. So here's my inequality. Y, we don't know the inequality symbol. Mx plus b, so negative 1/3 x plus 2. I'm going to replace the y with the negative 2. I'll replace the x with negative 1/3 times 6. The reason why I chose 6 is because when I multiply 6 by negative 1/3, it's going to give me an integer. It'll give me negative 2. Plus 2 equals 0. Negative 1/3 times 6 is negative 2. Plus 2 equals 0. If you compare the negative 2 with the 0, 0 is greater. So I'm going to say negative 2 is less than 0. And since it's a dashed line, it's just going to be less than. So my final answer, we have x is greater than or equal to 3. The other inequality is going to be y is less than negative 1/3 x plus 2. The other way that you can write that inequality is, since it was shaded below, you can say less than. If it's shaded above, you can say greater than. Try number 2. Again, just to make it easier, I'll do this one as number 1. I'll call this one number 2. Just to make it easier when I refer back to it later. All right, here we go. Line number 1, let's get the slope and let's get the y-intercept. So the y-intercept is negative 3. And the slope looks like it's up 1, up 2, right 1, so slope will be 2. Okay, so line number 1, I'm calling this one. has a y-intercept of -3 and a slope of 2. Let's pick a test point. Let's pick any point in the shaded region. I'm going to go with 0, 0, because that's the easiest one if possible. So let's test the point 0, 0. That must be true. All right, here's my inequality. Y, we don't know the symbol. mx plus b, so 2x minus 3. We're going to use 0 for y and 0 for x. So 0, we don't know the inequality symbol yet. 2 times 0 is 0, minus 3 is -3. So 0 is greater than -3, and since it's a solid line, I'm going to say greater than or equal to. Okay. Now let's do line number 2. The other way to think about that is for the solid line, line number 1, since you're shading above, it's greater than, and solid greater than equal to. That's the shortcut. Now let's do line number 2. Has a y-intercept of 2 and a slope of -1/2. Okay? Slope is -1/2. Y-intercept is 2. Let's use the same test point. Let's use 0, 0. Just because that's the easiest one. Must be true. You don't have to write that out. I'm just doing that so you know what I'm doing. Y, we don't know the inequality symbol yet. -1/2 x plus 2 because it's mx plus b. Let's replace 0 for y and let's replace 0 for x. So 0 being compared with 2. And it's less than. The quick way is since you're shading below line number 2, it's less than. But now I can write my final answer. The first inequality is y is greater than or equal to 2x minus 3. Second inequality, y is less than -1/2 x plus 2. Okay. All right, let's move on to the next page. State the vertices of the shaded region below, then state the point that maximizes the objective function, then state the maximum, and then state the point that minimizes the objective function, and state the minimum. Okay, so let's do the vertices first because that's the first part. State the vertices. I'll do it over here. The vertices are we have 2, 2. We have 5, 5. And then we have 10, 6. Okay, so those are the 3 vertices of the feasible region. 2, 2. We have 5, 5, and we have 10, 6. Okay, we have our objective function right here. So let's see which vertex maximizes it, and let's see which vertex minimizes it. I'll go in order. Let's do vertex 2, 2. Just going to recopy the objective function. And let's substitute and simplify. -3 times 2 minus 5 times 2. So that'll be -6 minus 10 is -16. Now let's do vertex 5, 5. Okay, we have 3 vertices. Let's do all 3 of them. Let's do vertex 5, 5 next. Okay. I'll just recopy the objective function again. Negative 3x minus 5y. So negative 3 times 5 minus 5 times 5. Okay, so that's going to be negative 15 minus 25. Negative 15, and you have minus 25. So that's going to be negative 40. All right, and then the last vertex is 10, 6. Let's do the same exact thing there. Copy the objective function. Substitute negative 3 times x, so negative 3 times 10. Minus 5 times y, so minus 5 times 6. I'll give you negative 30 minus 30, so that's going to give you negative 60. And now let's see what the maximum and the minimum are. Okay, so negative 60 is the smallest number there, so that's going to be the minimum. And believe it or not, negative 16 is the biggest one, so that's going to be the maximum. And let's just write that out. Let's write that out, 2 sentences. The minimum is negative 60, and it occurs at 10, 6. The maximum is negative 16, and it occurs at 2, 2. There we go. That looks good. That one wasn't that bad because it was already graphed for you. Now we're going to do one where we have to graph it ourselves. Okay. So let's do one that we have to graph ourselves. So same directions, but now we have to graph. This is the last one. Okay. So the first line has a y equals mx plus b. The y-intercept is 6. And the slope is negative 1, so you can go down 1 and to the right 1. Keep doing that. Let's graph that. I can tell you right now that one's going to be shaded below because it's less than or equal to, so the shortcut is shade below. If not, you can use a test point like you've done in the past. The next line, when you use the x and y intercepts, the x-intercept is when you ignore y. So the y goes away, okay? And then you have x equals 10. For the y-intercept, that's when you ignore x, so the x goes away. Pretend it's 2y equals 10, and then y equals 5 for the y-intercept. Let's graph that, and then let's draw our line. Figure out the shading by picking a test point. If you test 0, 0, you get 0 is less than or equal to 10, which is true. So you're going to shade below that line. X is greater than 0 and y is greater than 0 means you're going to be in the first quadrant. So this is going to be the feasible region right here. Do it in red. This is the feasible region. So when we mark up the vertices of the feasible region, we're going to have this vertice right there, 0, 0. There's this vertice, this vertex right there, 6, 0. Then we have this one, 1, 2, 3, 4, 0, 5. And then we have 2, 1, 2, 3, 2, 4. Those are our 4 vertices. Let's state them. Zero, 0, 6, 0, 0, 5, we said. And then the last one was 2, 4. All right, now we're going to test each one in the objective function and see what our minimum and our maximum values are. I'll go a little faster this time since we've done one just like this. I'll do all 4 vertices, so let's start with 0, 0. I'll copy the objective function above, which is 50x minus 30y. I'll do this for each vertex, so let's do it now. Next vertex is 6, 0. Then we have 0, 5. Then the last vertex is 2, 4. Let's copy all this down now and get it over with. You don't have to recopy the objective function each time if you don't want to. I'm just doing it for the video. Okay, the first vertex is going to be easy. 50 times 0 minus 30 times 0. That's going to be 0. All right. The next vertex, 50 times 6. Minus 30 times 0. Well, that's going to be 300. Okay. The next vertex, 50 times 0. Minus 30 times 5 is going to be negative 150. And the last vertex, 50 times 2. Minus 30 times 4. That'll be 100 minus 120 will be negative 20. Okay. Okay. So it looks like this 300 is going to be our maximum. And then negative 150 is going to be our minimum. Put those in 2 sentences to finish this off. The minimum is negative 150, and it occurs at 0, 5. And the maximum is 300, and it occurs at 6, 0. $300, and it occurs at 6, 0. All right. All right, that should do it. That is the end of the video on the review for the quiz. It was on writing systems of inequalities and an intro to linear programming.